In this video, we want to continue on with our introductory lesson to differential equations. In the last video, we talked about particular types of differential equations. In this video, we just want to begin to try to understand what it means to be a solution to a differential equation and how we might be able to solve those. So if we take a look at this particular example, here we have x double prime minus 2x prime plus x is equal to 3t minus 8. And we're saying that we want to verify that x equal to t e to the t plus 3t minus 2 is a solution to this differential equation. Well, if we know x is t e to the t plus 3t minus 2, x prime is, now we need to do the product rule for t e to the t because we're taking a derivative with respect to t here. That's our independent variable. So this is the first times the derivative of the second plus the derivative of the first times the second. And now we've taken the derivative of t to the t. And we take the derivative of 3t, so it's 3. And then derivative of 2 is 0. X double prime. Well, this is the derivative of t to the t again, which we've already done, so we can just rewrite that. And then we have the derivative of e to the t. And then we have the derivative of 3 is 0. And so this is equal to t e to the t plus 2e to the t. And now what we want to do is we want to plug all of this into our equation that we started with right here. Plug all of it into there and see if we do in fact get 3t minus 8. So x double prime minus 2x prime plus x is equal to, all right, x double prime, this is t e to the t plus 2e to the t minus 2 times x prime, which is t e to the t plus e to the t plus 3. Plus x, and x is the original thing that we're given right up here. So that is t e to the t plus 3t minus 2. And we go ahead and start combining everything. So we have a positive t e to the t. We have a positive t e to the t. And we have a negative 2t e to the t. So those all cancel. Then we have a positive 2e to the t, and we have a minus 2e to the t. So those cancel. And then we have 3t from here, and a minus 2 and a minus 6. So minus 2 and minus 6 makes a minus 8. So in fact, we do get the 3t minus 8 at the end here. So x equal to t e to the t plus 3t minus 2 is in fact a solution to this differential equation. All right, so we'll go ahead and erase all of that. Move on to the next page to do the last couple of examples. This takes a moment to erase. Sorry about that. Just realized there's a clear button. I'm still learning just like all of y'all on how to do all this stuff. Move over to page 3 here. And we want to look at the general solution of an nth order differential equation on interval I is an n parameter family of solutions that contains every solution defined on I. Well, let's start to look at a few examples of such a thing. So we want to solve the differential equation x prime equal to t squared. We know how to do this already. This is stuff you've done back in Cal 1 even. Right, so if we have x prime is equal to t squared, we want to solve the differential equation. What does that mean? That means find x. Find the equation x, right? This is some function of t, so x of t. So we want to find the equation x of t. Well, how do we do that? If we just have x prime is equal to t squared, then we just take the antiderivative of both sides, right? We just integrate both sides. So the integral of x prime with respect to t is equal to the integral of t squared with respect to t. So this is x is equal to t cubed over 3. But of course, we need to add any constant. So we get x is equal to t cubed over 3 plus c. All right, so that's our solution to that first part of the problem. And now let's do number 2. Part 2 here, which is solve the initial value problem, x prime is equal to t squared, where x naught is equal to 1. So we just found the general solution of x is equal to t cubed over 3 plus c. And we're now given that x of 0 is equal to, well, this is 0 cubed over 3 plus c. And we were told this is equal to 1. This implies that c is equal to 1. So our initial value problem is x is equal to t cubed over 3 plus 1. Okay, and it really is that simple so far. It certainly gets more complicated as we move later into the semester, but so far it's pretty straightforward. Hey, we'll do a similar thing, but for a second order differential equation now. So x double prime is t squared. We want to find x. So this means x prime is equal to t cubed over 3 plus c. And if we take the integral of that, or the antiderivative of that, we find that x is equal to t to the 4th over 12 plus c, and we're going to call this c1 times t because we take the antiderivative of the constant c. We're going to call that c1 here because we're going to have to introduce another constant c2 now when we take the antiderivative of x prime. So that is our general solution. And we take that and we solve the initial value problem. So we notice that x prime of 0 is 2. So x prime of 0 is equal to 2. So this is t cubed over 3 plus c1 is equal to 2. T cubed, whoops, I should fix that real quick. This is 0, t is 0, so this was in fact 0 cubed. And so this tells us that c1 is equal to 2. And then we keep going. So x of 0 is 1, so x of 0 is equal to, this is t to the 4th, so it is 0 to the 4th over 12, plus c1, which we saw was 2, t, which was 0, plus c2 is equal to 1. Right, I'm just getting that from here, right? X of 0 is equal to 1. So this tells us that c2 is equal to 1. So if we combine all of that stuff, c1 is equal to 2, c2 is equal to 1, we get that we plug in those into this equation here. And we get that x is equal to t to the fourth over 12 plus 2t plus 1. And that is written down at the bottom. Here were our solutions. All right, and that ends this video.